Next is filters. So as we know that the output of rectifier is a pulsating DC output. Output of rectifier is a pulsating DC output. That means the output of rectifier is a fluctuating. Output of a rectifier is a fluctuating, and this fluctuating or pulsating DC output of rectifier consists of AC components. And those AC components we called it as ripples. So this pulsating or a fluctuating DC output, it should be converted into a smooth or a steady DC. This pulsating DC output of rectifier, it should be converted into smooth or a steady DC. So to convert this pulsating DC output into a smooth or a steady DC, the circuit has been used. That circuit is called as a filter circuit. So this filter circuit is used to minimize the amount of AC components. Those AC components are present in the pulsating DC output. So the filter circuit is used to minimize the amount of AC components present in pulsating DC, or the filter circuit is used to minimize the amount of ripples present in the pulsating DC output of the filter. Now there are certain types of filters, or you can call it as certain types of filter circuits. So the first type of filter circuit is capacitor filter. The second type of filter circuit is an inductor filter. The third type of filter circuit is LC filter. LC filter means it is a combination of inductor and capacitor. And the fourth type of filter is RC filter. RC filter means it is a combination of resistor and the capacitor. So this is the basic function of filter, and these are the types of filters. Next is the first type of filter. That filter is capacitor filter. Now see this figure here. This figure shows the circuit of capacitor filter, in which this capacitor is connected after the rectifier, and after that capacitor there is a load resistance has been connected, and across that load resistance we will get the DC output. See this is the load resistance, and across this load resistance we will get the DC output. So this is the circuit of a capacitor filter, in which after the rectifier there is a capacitor is connected, and after that capacitor there is a load resistance is connected, and across that load resistance we will get the DC output. So in this circuit here, the capacitor and a load resistance RL. The capacitor C and the load resistance RL, they are in parallel with each other. They are in parallel with each other, and this capacitor C is connected parallel with the rectifier circuit, connected parallel with the rectifier. So because of that, this filter circuit is known as the shunt capacitor filter. This filter circuit is known as the shunt capacitor filter. Why? Because the capacitor C is connected parallel to the rectifier, or is connected parallel with the rectifier. So because of that, this filter circuit is known as shunt capacitor filter. Next we will see the working of this capacitor filter. Now see here, the output of the rectifier here, it is a pulsating DC output, and this output of a rectifier is given or is applied to the capacitor. So the output of the rectifier is applied to the capacitor. Now the capacitor has a tendency to charge up to the peak voltage, and this capacitor discharges when the input is less than the peak voltage. So the capacitor, it has a tendency to charge up to peak voltage, and it gets discharged when the input is less than the peak voltage. So in this capacitor filter, the capacitor it charges through the rectifier. And this capacitor it discharges through the load resistance RL. So in this capacitor filter circuit, the capacitor charges through the rectifier, but it discharges through the load resistance RL, and that load resistance is connected parallel or is applied parallel to the capacitor. The rate of discharge of capacitor, that depends on the RC time constant, and this rate of discharge of capacitor, the magnitude of that can be calculated as time t is equal to R into C. But here the capacitor is discharges through the load resistance RL, so we have to take here RL into C. So the discharge of capacitor depends on RC time constant, and this time constant is given as time t is equal to RL into C, and this discharging of capacitor is basically slow. Now see this waveform here. In this waveform, this is a rectifier output. Here has been shown. So when the output of a rectifier output of a rectifier that increases from 0 to the peak voltage here. See here, 0 to a peak voltage. Then the capacitor charge to peak voltage. See here, this is the charging of the capacitor. So this is the output of the rectifier has been shown here, and when the rectifier voltage increases from 0 to the peak voltage, see here, this is the peak voltage that we will take it as Vm here. So as the voltage of rectifier increases from 0 to a peak voltage, the capacitor immediately charged to a peak voltage. See here, the capacitor charges to a peak voltage, and this charging of a capacitor is shown, see here, is shown in this waveform here from A to B. And when the voltage, the output voltage of the rectifier is decreases from the peak value to the minimum here, then the capacitor starts discharging through the load resistance RL, and it discharges slowly. See here in this waveform, see this portion from this B point to C point. Here, when the output voltage of the rectifier decreases from its peak value to its minimum, then the capacitor starts discharging. Capacitor starts discharging through load resistance RL, and it discharges slowly, and that has been shown here with the portion BC. See here, capacitor discharges slowly. After that, again the output of the rectifier is increases from its minimum value, that is 0, to its peak value. Then again the capacitor charges here. Capacitor charges, see here, portion C to D. Capacitor charges portion C to D. Then again the output voltage of the capacitor decreases from its peak value to its minimum value. Then the capacitor discharges through the load resistance RL, and that has been shown here with the portion D to E, and this discharging of capacitor is slow. Again, the output of rectifier increases from its minimum value to its peak value. Then again the capacitor charges to its peak value. Then the output of rectifier decreases from peak value to its minimum value. Then the capacitor discharges through the load resistance RL, and the process continuously repeats here. Process continuously repeats. Now see in this waveform here, this waveform with the red line, it is the charging and the discharging of a capacitor, and from this waveform, this is the filter output here. This is the filter output with this red line. With this red line, it shows the filter output, and this filter output is what? It is a DC output with the minimum ripple here, with the minimum ripples. So see here, this filter output is what? It is the DC output with the minimum ripples, and it is almost a constant. It is almost a constant DC voltage. So this filter output here, it is the output having a DC with minimum ripples. So this filter output having DC with minimum ripples, and it is almost a constant DC voltage. So from this output of the filter, we can write here the capacitor acts as an open circuit. The capacitor acts as an open circuit for DC, acts as an open circuit for a DC, and it provides, this capacitor, it provides the low reactance path for AC components, So the capacitor acts as an open circuit for the DC components, and it provides a low reactance path for the AC components of the current. So therefore, as the capacitor acts as an open circuit for the DC components, so these DC, they passes through the load resistance RL, the component of the DC current. They passes through the load resistance here, and as they passes through the load resistance, across that load resistance, the DC output voltage produces. And as the capacitor provides a low reactance path for AC components, so these AC components, they bypasses through the capacitor, and they will go to the ground. So see here, these AC components, they bypasses through the capacitor to the ground, and the DC component, they passes through the load resistance RL, and across that load resistance RL we will get the DC output voltage. But here, not all the AC components, they bypasses through the capacitor to the ground. Small amount of AC components, they passes through this load resistance RL, and because of that we will get the minimum ripples in the DC output voltage that we will get across this load resistance RL. So across the load resistance RL, we will get the DC output voltage with the minimum ripples. So we can say that after connecting a capacitor filter after the rectifier, this capacitor filter, it will minimizes the ripples. But it will not 100% minimizes the ripples. So across that output of the filter, we will get the DC output with minimum ripples. But that DC output is what? It is almost a constant DC voltage. That means it will consist of a minimum ripples or a minimum AC components. So these are the circuit diagrams and the waveforms of the capacitor filters here, and this is the working of the capacitor filters.